Moving on to our Decarbonizing Coffee, Greening the Coffee Cup panel. Recently, many major international coffee companies, including Nescafé, Nespresso, Lavazza, and more, have been exploring how to decarbonize their supply chains. Biochar, as part of this effort, is gaining increasing attention, and our panelists are at the forefront of this. IBI's board chair, among the many biochat hats she wears, Kathleen Draper, will moderate this panel. Over to you, Kathleen.
Thanks, Wendy Lou, and hello again, everyone. I am really pleased to moderate this particular panel today because I've spent a significant amount of time over the past 7 or 8 years writing about the benefits of biochar production and use within the coffee industry. I've also taught smallholder coffee growers in Latin America how to make it and use it on their farms, and I've worked with engineering students trying to optimize the collection and carbonization of coffee residues, such as chaff from the roasting process combined with spent coffee grounds. This industry is ripe for what I call a decarb makeover. And we are, as Wendy Lou said, starting to see more and more coffee companies interested in incorporating biochar into their sustainability plans. We have gathered 3 different individuals, all very knowledgeable, that bring a different perspective to this topic. And first up is Axel Reinaud, who has, I don't think, been in the biochar world full time for all that many years, but I think it's in his DNA, as both his father and his son have been very involved with biochar for quite some time. But his background in management consulting has been put to great effect in setting up biochar production facilities in Africa and soon in Brazil. Axel, would you like to share some of your story?
Thank you, Kathleen, and hello, everyone. Very happy to be on this panel. And as you were saying, Kathleen, I think coffee is really one of the prime applications of biochar, and with I think really a huge business case, both on the financial side and on the climate side. And that's what I wanted to share with you today. I don't know how to put the slides. Okay, wonderful. It works like magic. So as a quick introduction, I'm the CEO of Net Zero, which is a company created about 2 years ago to try to bring biochar at scale in the tropics. And actually, we started with coffee, working out of coffee husk with the first facility in Cameroon, and we're now expanding. So we have some experience both on producing biochar out of coffee residues and usage of biochar on coffee trees. And that's what I wanted to share with you today. So maybe we can move to the next slide. So Net Zero, we are a startup. We focus on long-term carbon removal, and I'm not going to talk about all the benefits of biochar on carbon removal because I'm with a lot of experts today. What we do is we use the biochar as soil amendment for agriculture. And this is a lot of companies are doing that. What is different is that we operate in tropical developing countries. And we operate an industrial model, so with relatively large facilities operating 24/7, and so with the objective to produce a quality biochar at a very low price, a very low cost. And so that biochar can be sold or sometimes given to farmers so that they can use it in a very circular model. And so we started out of coffee. And I think that's a very good application for biochar. Maybe we can move to the next slide. So in coffee, biochar helps tackle a number of very important topics. Of course, the climate topic and the reduction of greenhouse gas emissions. There are some places where 1 kilogram of green coffee corresponds to 4 or 5 kilograms of CO2 emitted. And here, biochar can bring both reduction in fertilizers and insetting. Of course, there's the whole topic about resilience and improving the soil health. And so biochar is also going to be very important there. There's the whole topic about yield and basically the trade-off you can do between the amount of biochar that is put, the reduction of fertilizer and the improvement of yields, with very positive benefits, of course, also for the farmers in terms of standard of living. Quality, because it allows to transition to organic farming, and then all the co-benefits that are well known with biochar actually are amplified in the case of coffee. Maybe we can move to the next slide. So the model of net zero is a very circular model. So local farmers, we gather the coffee husk from local farmers. Those coffee husks are then turned to biochar.
We're having a little bit of difficulty with lag.
And subsidized. So you have a long. Okay, sorry. I hope it works. And so I hope you can hear me. So there's this long-term carbon removal, also emission avoidance, and improved quality of soil, and that's the first set of benefits. And then there's the benefits linked to electricity and access to energy. So it's a very local model that works with the local farmers, and so everyone benefits from basically a better usage of the crop residues. Maybe we can move to the next slide. The result of biochar on coffee can be quite spectacular. Here I quote a study that was done actually about a year ago, where you can see the impact of biochar versus a baseline. So if you put fertilizers, you quasi double the yield. But if you reduce fertilizer by 1/3 and put biochar, then you can improve yield by 14%. And if you keep the level of fertilizer and put biochar, you can improve by 33%. And so that's the core of the economic and carbon model that we're trying to develop. If we go to the next slide, you can see that from an emission standpoint, these are numbers from Brazil. There's about 3.3 kilograms of CO2 per kilogram of green coffee, and you can reduce that by about 40% through an effect of yield for the same amount of CO2 emitted, lower usage of fertilizers, and insetting of carbon. And so the very significant impact on CO2 is also comes along with a better margin. And so we estimate that you can get about 0.2 euro of additional margin per kilogram of green coffee because you save on fertilizers and because you get higher yield. So biochar is a solution both where you can have a positive climate impact and a positive economic impact. And I think that's very critical to our model. If we move to the next slide. Net zero, so we started on coffee. We have a plant running in Cameroon, in a region which is the heart of the coffee production in Cameroon, with about 5,000 farmers, and we get the coffee husk from the dehusking facilities where those farmers bring their harvest. And then we are completing, it should be finished by mid-January, our first plant in South America, in Brazil, in the region of Matas de Minas. Here it's larger, cooperative, it's 10,000 farmers. It's also much higher yield, so the amount of coffee husk is actually very, very big. And we will have a plant about double the size of the one in Cameroon as a first one. And then we have a whole pipeline of plants that we are going to build next year. Include if we go to the last slide. Can we move to the last slide? Hello?
Axel, are you able to see me?
Yes.
Can you see the slide? Do you need
okay, great.
The next one?
Yeah, I can see the slide. Yes.
Okay,
so sorry, everyone. I'm in a very bad place for network. So just to conclude, and then maybe the others can jump in. We are really trying to build a model that is coffee specific. So how you source the biomass, how you produce the biochar, how you use that biochar in coffee, and all the business model that goes around it, the climate model and the economic model. We want to to have something that is very sustainable. So we optimize the value by providing a long-term carbon removal solution, and we provide renewable energy. And so this is a very sustainable model. It's a model that is end-to-end. So we build and operate the plants. We actually do the R&D. So we design the equipment, we build the plants, we operate the plants. And so that allows to optimize the end-to-end model. It's something that is very inclusive. We work within value chains and within, of course, the coffee value chain with coffee operators, with actually brands, large brands. And so that proves very efficient to optimize along the value chain. We have a model that is very efficient in terms of CapEx and OpEx, and it's built to be scalable. Given the business model, given the technology, and given the end-to-end model. And so our priority goal in the next years is to scale this model in coffee. Of course, Brazil is a land of opportunity for that, but there will be many other places where we can go. I'm going to stop here. I'm sorry for if you had some hiccups in the network, but I hope everyone was able to hear, and happy to have a discussion offline. Thank you very much.
Thank you so much, Axel. Very interesting. If you're still on, I would say, hey, how about hosting a biochar study down in Brazil once you're up and running? Anybody else like to join me on that? Next up, we have someone from one of the world's largest green coffee service companies, the Newman Coffee Group, Hans Faessler, who oversees the NKG Tropical Farm Management Group, is joining us. And I think, Hans, you may have been one of the very first people working with biochar in coffee. So I'd love it if you would join us and tell us about what you're doing there.
Right. Thank you very much. Yeah, pleasure to be in this panel tonight or this morning. And I came in here because I wanted to show two models of how we apply biochar in two plantations in East Africa. And you see already the first slide up here. We do basically we produce the biochar with very simple means locally, and incorporate it into compost from coffee production byproducts. And we apply this only into field renovation programs. We in all our farms, we have a firm program of field renovation. That means field renovation is something that happens every year in order to maintain the plant age average. We don't want to have overage plantations, so we have a firm renovation program, and that offers the opportunity to incorporate this carbonized compost into the fields, basically into the planting holes, where we see the best effect. So here in the Kaveri coffee plantation, you see that the compost mix is pulp. We use pulp. We have a dedicated compost area in the farm where we bring all the pulp, or a large portion of the pulp, and which makes 50%, and then husk 20%. We are hulling on the farm, and then char at 20%. And then we take the 10% forest soil as an inoculum for the right bacteria. And then we have, of course, the process of turning it. We imported the right machinery for that. And just in order, of course, to maintain the temperature of the mass. But what I would like to draw your attention to is the volumes, the amount which we apply per hectare. That means per planting hole, we're using 40 liters of such carbonized compost, which leads them to this volume you see to the right, about 53,000 liters per hectare, which might be a large volume in relation to what others are doing. When we do the application, then this compost, we also add mineral fertilizers to make sure there's enough nitrogen for the bacteria to multiply fast, because it really heats up very fast. And in order to have a proper breakdown of the mass, we add this fertilizer during the compost production. At the density of about 1,300 plants, which is about a third more than what is the normal planting distance in Robusta. It's a Robusta plantation, comes to this volume of char, means about 5.3 tons or 6.6 tons of actual char per hectare. Below, you see a small table. Now, of course, I need to warn you to believe that this is only due to the char. It's more like another model of cultivating fields. That means it's not only the char, there are other elements playing into this, because we are ripping the soil. Novice, maybe you take the next slide, please. That may be easier to explain. Next slide, please. Yeah, here you see that we are producing the char in a very simple manner. To the left, there's a simple drum which is used to produce char from husk, but we produce also char from wood, and then say the char is then made into smaller material with a simple maize huller. And to the right, you see then the machine to turn the char, and you see the steam, how hot this gets. This to just show that it's easy and it's possible to produce that in a very simple manner. The top right is then basically the final product, which is the carbonized compost. Next slide, please. Well, that's the Utengule coffee plantation, the southern highland of Tanzania. And this is an Arabica farm, which with much higher planting density, and the composition of the compost is different. You see, we use about 30% pulp. We have then parchment, shell by 20%. And there we have the possibility to buy cow dung, which goes really well into compost, but again, the 20% char, and then either NPS or DAP fertilizer 1 kilo per cubic meter. And then we turn, and then we basically light up the compost heap, and that takes normally about 6 weeks before the temperatures start to fall. I will also again draw your attention to about the amount which we apply, which is 20 liters per hole, but at the density of 4,100 plants, leads to over 8 tons of actual char per hectare. Again, you see that the effect of it is phenomenal. It's really the impact. Again, I must warn that it's not only the char, but is a certain other measures which leads to a way better production than the way it was done before. Next slide, please. There, see the application. You see the woman putting a 20-liter bucket in the hole. You see the left how you see this nice carbonized compost, but other measures which I say is in this concept has nothing to do with char, but we rip the soil, and in the middle you see this a picture of Indigofera spicata. This is a soil cover which also plays into a much higher productivity. But maybe interesting for you to see is the top right, the hand with the material. In this case here, due to, interestingly, a machine breakdown, we couldn't finish the actual composting process completely. and you see that the material is not completely decomposed. But we believe that this sort of method of carbonized compost, that the mycorrhiza activity develops much faster, and also thanks to the ripping with the bulldozer, that the spreading and the effect on mycorrhiza fungi development is so much better with this material and faster, that we see a plant growth which is simply phenomenal. And so we're doing this already in the fourth and soon in the fifth year, and we see also a very consistent production of those coffee fields. So that's basically the result of how we work. Maybe last slide. As you can see, we are a user of biochar. We are not a researcher, but in order to show in more research, the more in a scientific way, we would like to have more scientific research to really analyze the cost benefit. As I say, we are doing biochar and carbonized compost not because of the carbon debate, but simply because of the effects in the agronomic model. And there, of course, there's all these questions. What are the cost benefits? What is the balance of carbon, and so on and so on. We see this all. I don't need to repeat all of that, but that's what we would be interested in, and we would offer also this as a place to do such research. Thank you very much.
Thank you very much for all your pioneering efforts there, Hans. And next up, we have Hannes Zellweger, who has been working on carbonizing coffee residues in a growing number of countries. And I believe you're calling in from Brazil, but you're normally in Switzerland. Is that right?
Yes.
All right. I'll hand it over to you.
Thank you very much. Yeah, I just have the opportunity to be in Brazil, to visit a lot of coffee farmers. I would like to thank you for the invitation to talk about the decarbonization of the coffee sector. My name is Hannes Zellweger. I work for DSS Plus. We are a consulting firm, and we support and promote and enable companies or sectors to decarbonize. And in the past years, I've been developing many biochar projects around the world. Next slide. So yes, that's me. So my passion is to turn waste into a business case. So it can be coffee, but it can also be banana, cashew, whatever waste there is. The negative emission technologies with a very strong focus on biochar, and of course lately the combination of biochar together with the regenerative agriculture practices. Next slide, please. I think just a little bit the context, a few messages here. I'm sure you have all seen something similar like that. That the big, let's say, big actors in the coffee sector, they have signed somehow to one of a decarbonization strategy. It can be a reduction, it can be the Science-Based Targets Initiative, and on and so on. So here are a few comments. So one is we also need a reduction. Only with negative emission technology like biochar, we will not solve it. So I think it's really also about focusing on how to get higher yields with the same fertilizer input, improve agriculture practices, change to other fertilizer, improve logistic, everything. It is a bit seen currently that with, let's say, agroforestry and biochar, we can do the decarbonization of the coffee sector, but I think it's also biochar is just, let's say, a puzzle in this topic, but important puzzle, but not the silver bullet. Next slide. For me, what is also very important is I think we cannot talk about the coffee sector. The coffee sector in Brazil, we see a picture on the right side, is just very, very difficult or different than the coffee sector, for example, in Colombia, where plantations are on a steep hill. It's very difficult for logistics, the know-how, the operation. So I think it's really important also to distinguish in which context, in which ecosystem are we working in. And one of the most important points, I would say, for biochar to be successful is the question of how can we integrate that in the operation? How can we make that happen, taking into account their operation? So how are they organized? What kind of staff do they have? What kind of practices they already use? And even in Brazil, just the last 2 days, I saw 3 different farmers, and they all had a different practice. So one is using compost, the other not. One was managing actually the compost, and others not. So I think this is the most, to be successful in the future, I think this is the most important part. In addition, what just Hans said is really getting data. I think there's still a lot of or not enough proven data that the biochar is having the effects that we foresee. So I think there it's a huge gap, and this has to be overcome. Then maybe a third important point is also, I think we should not talk too much only about biochar. It's always a blend. So a composting facility, a charging of the biochar, which is related. So I think sometimes it's a bit misleading to just say, yeah, we put biochar into the soil. I mean, we all know it's a sponge effect, and we will have negative impact if we just put biochar. So I think we should rather, as also Hans said, it's a carbonized blending or compost which has to be applied. Next slide. Here maybe just a few points on the impact. I think Axel also mentioned it. So there's a huge variety on what actually, what kind of impact do we have in coffee production. For me, a cup of coffee is like driving 1 kilometer by car, let's say an average of 120 grams of CO2. A third is from the hot water, a third is from transport and packaging and so on, and the third, and this is where we work mainly, is on the green coffee supply, which is, I think, where most of the action currently is taking place. So there we have an impact of 3 to 8 tons of CO2. I took an average yield of maybe 1,200 kilos of green bean equivalent per hectare. So 3 to 8 tons of CO2. If we look then at the application, I would say the studies, they say, yeah, we can go up to, let's say, 7 to 10 tons per hectare. It's more or less equal to 17 tons of CO2. So, yeah, in 4 or 5 years, we will have, somehow the credits over. So, if we only look at the effect that we want to have in application. If we want to have an effect only in the sea sink, then we can maybe go up to 20 tons. Then it's a solution for the next, let's say, maybe 10 years. What we are looking at always is we look at what kind of potential do we have per hectare. So we not only have the husk, but we have also the stems, we have the leaves, we have agroforestry, and we see what can we actually take out of the system, making sure that we have enough biomass to make the blend to be applied to the soil. So we don't want to take everything out. We want to have at the end a good composting to have the increase of yield which is expected. So Then we can look at that as a hectare, like a productive area. But of course, we can also extend a bit and say, yeah, we look at farm management, and maybe we even look at the landscape approach. So this is a bit where we are, and it shows a bit that, yes, it has a huge potential, and let's use this potential, but I think it has to go along with reduction, and it has to go along with other decarbonization measures. Next slide. So we as DSS Plus, we don't sell technology. So we always try to bring the knowledge to a country, for example, Brazil or Colombia or Peru, and we enable people to have the technology. And pyrolysis is still a technology. So first of all, we have to have someone who's producing it. Our goal is always that we have a local manufacturer and we're not exporting, for example, from Switzerland to Nicaragua. So we have a local manufacturer who can build the machine, but can also maintain the machine and make a service and so on. And I think there is room for many different technologies. There's room for batch system if we go maybe to Indonesia and we have very small farmers. The Kontiki or a Tilud. Then we have the semi-industrial, which we are focusing mainly, discontinuous already, which are really building on the technology they already know in the countries. So they have dryer systems, so we combine local dryer system with pyrolysis system. And of course, we also have the potential, Brazil, maybe different countries to go, like Axel, with this very big continuous pyrolysis system. So I think there's room for all the technology. It's important that they know how to operate it. It's easy, but it's not that easy. And it's important that they know how to make blends and to involve it in real business cases with hard facts. Next slide, please. So yes, this is us. So what we do, so we have experience from Switzerland. We bring this know-how to other countries. We do technology transfer. We do a lot of business case development. We do a lot of training, on-field training, composting, because we really think that like that we can really scale up and have the impact that we would like to generate. Next slide. This is an example, Vietnamese pyrolysis system produced in Vietnam, about 30 kg per hour, a range depending on what kind of operation time they have, year 150 to 300 tons of CO2. No, it's a biochar, sorry. Yes, next slide. And here, an example of in Peru, where we really are building, and it's also important to build on the know-how they have. So a lot of this local manufacturers, is also very dependent on what kind of knowledge they already have. So we always try to train them and to also learn. It's really a co-creation. So taking what they can or what they do well and then build with the know-how, the Swiss know-how, we build on this. Yes. Next slide. So maybe a few challenges. There's a huge potential, and I think coffee is compared, for example, for sugar and other commodities. I think it's really upfront. There's a lot of movement in the regenerative. I think the biggest challenge, and that's the same in Brazil, in Colombia, as in Switzerland, is how do we change the behavior of farmers? How does he understand? They don't know what biochar is. They don't trust maybe that we will have the impact. So how do you convince, how do you create programs that the farmer really understands what to do? So the commitment of the farmer, the commitment of the local manufacturer in not only decarbonize, but also in go towards this regenerative, compost-based, carbonized blends of fertilizer. Then I think what is also important is the opportunity is the sharing of income from the carbon credit. So I think nowadays there are also the potential for small-scale pyrolysis machines that also the farmers at the end can somehow benefit from this market. That they can sell the credits, that they can improve their production by reduced fertilizer costs. I think there's also a huge potential for maybe areas where the production is at risk. It's a very vulnerable landscape where there's not enough water. There's just not the perfect conditions for coffee production. So my wish is that at the end we need data. We can focus more on real studies, on really good studies. That in each country we have producers which can produce a pyrolysis machine adapted to the local context, and that at the end we have somehow a shared value creation if it comes to biochar and carbon sinks. Thank you very much. That's from my side.
Thank you so much, Hannes. That was great, and I think I just missed seeing your pyrolysis equipment in Peru. I was about 5 minutes away, but I didn't realize it at the time. So anyway, we have time for a few questions, and I know Axel has to go. So I'm trying to see if some of these questions are kind of technical, and I'm not really sure if you'll be able to answer them, but this one possibly so. And it was about the carbon footprint for transportation of biomass to a centralized facility. Is this something
Hello.
Yeah. I don't know if you heard me.
Yeah, I heard you. Sorry, we really have to leave, but actually the carbon footprint is quite low because we source the biomass like 10, 15 kilometers around our plants. And so actually it's already centralized in de-husking facilities. And so the transportation is really marginal. Actually, in the LCA, of course, it has a little bit of weight, but it's the magic is that because it's a very circular model, there's little transportation upstream and even downstream of the biochar back to the fields.
Great, thank you. And if you have to leave, I understand. Next question I think is for Hans. The question is, how much wood do you need to burn for 1 drum of your char? And I don't know that you're using that drum method for all of your biochar production, so maybe you could speak to that as well.
No, I can't answer that question because I don't know how much we use. We use in that case of that drum, we use coffee wood from coffee pruning. That's wood coming from pruning. So it's basically produced in the coffee field, and part of it is used to produce the energy to produce the carbon. And we produce also a lot from actually coffee wood. Just make coffee wood do carbon in a traditional way. That's not as clean, of course, as pyrolysis, but we are just not organized, or say we have not yet the system in place to use pyrolysis to produce the char. So we use just simple method, but that would have to be evaluated. We haven't done that.
Right. And of course, if you use a soil pit kiln or any kind of flame cap kiln like a Kontiki, the coffee prunings and the stumping is actually what you're turning into biochar. And you can probably get about 20% yield if you're doing it right, I think. Hannes, is there anything you want to add on that?
No, but it exactly shows. So there's an interest from the farmer, but having access to really good quality biochar with a machine which is suitable for the farm, it's key. So you cannot come to Brazil with a Kontiki, they will run away. And on the other hand, you need good quality. You need also this integration in a farm. So labor costs, when do they have material, how do they put it, reliable machine. I think it's really this where we need the joint effort, everyone together with pioneer farms like Hans has, together with machine producers to answer actually to this demand. I think we are not yet able to follow the demand from which let's say the big actors in the coffee sector would like to have.
Yeah, maybe a point to add here is that as I mentioned before, we have a field renovation program taking place every year, and in cases where there are shade trees, part of those shade trees have to be removed before one plants a new field, because often these shade trees are not in line with the coffee line, so they disturb the operation. And there are certain shade trees which cannot be used for timber or anything. It's just not good wood. That qualifies perfectly to make char. And so we have ample material to produce in a very simple way this char, and then crush it and incorporate it into the compost. So we are never short of raw material.
I agree with that. There was a question about whether it's pelletized or pre-processed, but I think most of it you can micronize fairly simply on farm. Is that right? Just by crushing?
Yes. Crush it by hand or with a simple huller or something. That's fairly simple. It's brittle anyway, so it crushes quite easily.
Mm-hmm. Okay, I'm going to take just one more question because we have another, we're running into the other groups.
Yeah, maybe a point, I think, one point which is interesting, always talking about the increase of yield. Maybe Hans, you can comment. I mean, in Brazil, they will never have a 30% yield increase. They are so professional already. It's not about, I would say, but you correct me, Hans, but it's not about yield increase. It's to maintain the big yield with maybe less fertilizer. But I would say a 30% increase yield by applying biochar it's difficult to achieve. I don't know how you see that, Hans.
Yeah, sure. There's the agronomic concept, and char can play a role in it. What I noticed in Brazil, there is an increasing number of farmers producing compost, by the very valuable byproducts. And so now, as I say, when we have to prove the case of the value and the impact of char onto production, and not this on the short term, but also in the long term, that it works in nursery has been proven several times. Even ourselves, we made trials in the nursery with different levels of char into the mix of the backfill. It works. But how it is in the field and how it works over time, these are the things that have to be researched and give more accurate answers, which then would motivate probably also farmers in Brazil of using more char and carbonized compost.
Yeah. Well, I do need to wrap it up. Thank you both for hanging out with us and informing everybody. If you have time to join the room that's been set up for this panel, that would be great. And I'll turn it back over to you, Wendy Lou. Just a reminder, you have to exit this and go to the next panel. Thank you.